Hi, let's talk about waves. Now, there are many different aspects of waves that really need to address, but in this particular talk, we're going to be talking about the two major types of wave. There's longitudinal waves and transverse waves. Now, waves is any sort of propagation of information that goes from one space to another, and that's a bad definition, but we're going to go with it for right now. So, anyway, start out with the classic wave demonstrator, the Slinky. You know, what goes up, downstairs, alone or in pairs, and makes a slinkety sound. Now, I've added a piece of duct tape to it just so that you can look at a particle. Now, if I extend this, try to get the right background, I extend it, you can see the tape right here. Moving back, all right, right there. Now, the two basic types of waves, notice if I stretch the bottom part, it's lowering. When I let go, that duct tape is going up and down. So the wave I'm sending is parallel to the motion of this particular particle. So this is in the medium being the Slinky, and this is a piece of tape in that medium. This is marking a position, and notice that tape was moving parallel to the direction of propagation of the wave. The wave went from down below up top, and the piece of tape went up and down. That is called a longitudinal wave, or a compression wave. Longitudinal or compression wave. Classic example of a longitudinal compression wave, just other than the Slinky, is sound waves. Sound waves are compression waves, because when I speak, the sound, I'm basically compressing air, and then I'm rarefying air. So, but the air basically is moving along this direction. The air molecules are moving back and forth if I'm speaking this way. So if I'm over here, the sound waves are moving back and forth like the air molecules are moving back and forth like this, and the sound wave is moving outwards. So that is a longitudinal wave. Now, transverse wave, okay, looking at that piece of tape again, now this time instead of coiling down like this, like it did for the longitudinal wave, this time I'm just shaking the bottom, and notice that that piece of tape is moving back and forth. The wave I'm producing is going this way, the piece of tape is moving back and forth, and like this, the motion of the particle is perpendicular to the direction of the wave. That is a transverse wave, or a shear wave. Now, why is this important? Well, it's important to realize that, let's say there's an earthquake. You get transverse waves and you get compression waves and or longitudinal waves, both. Now, because transverse waves, let's think that, well, actually, we'll put that in the next video. These are the two basic types. We'll go into more detail in just a moment.